Hello everyone, so we are going to start on 6.2 bisectors of triangles. And so we talked about perpendicular and angle bisectors of two figures, and so now we're going to elaborate more on those bisectors in triangles. So instead of just having one bisector in a triangle, you might have more than one, or in this case we could have three or more. So pardon me momentarily as I zoom in. So let's start off with some definitions. So I have concurrent, the point of concurrency, circumcenter, and incenter. So for concurrent, that is when three or more lines So concurrent is when three or more lines, rays, or segments intersect in the same point. So, keyword here we might have forgotten is intersect. Intersect does mean to meet or cross. Okay, so this means if I have three or more lines, let's say I had three, that very point in the center, these lines are the concurrent lines that meet at this point. And this is called your point of concurrency. So point of concurrency is the point of intersection of the lines, rays, or segments. So the middle is called your point of concurrency. Now your point of concurrency can also be called a circumcenter or an incenter. For circumcenter, this deals with more of the perpendicular bisectors. For the incenter, this deals with more of the angle bisectors that we talked about in our last section. So circumcenter is where three perpendicular bisectors are concurrent so it's called a point of concurrency. So if I have three perpendicular bisectors that cross, it's called that point of concurrency is called a circumcenter. For an incenter, this is where I have three angle bisectors that are concurrent. So it's called a point of concurrency. But this point of concurrency is called the incenter. So perpendicular bisector's point of concurrency is called the circumcenter. The point of concurrency for three angle bisectors is called the incenter. So those are our definitions that we'll be coming across today. And we'll have two theorems, one for circumcenter and one for incenter. So the circumcenter of a triangle is equidistant from the vertices of a triangle. So the vertices, remember, are pretty much your endpoints. So A, B, and C are your vertices. Those are your points in those triangles. Equidistant, remember, sounds like equal distance. Okay? So this means that if P, D, and E, so PD and PE and PF, so these are not in line with a vertice or a point. So I'm going to circle these, and when I circle these, that means these are your perpendicular bisectors. So these are your perpendicular bisectors. Then PA, PB, and PC are all congruent. So PA and PB and PC are all congruent. Note these all touch the vertices. So these are what we are trying to find. Okay? So towards the back, we have our end-center theorem. So end-center, the end-center of a triangle is equidistant or equal distance from the sides of the triangle. So this one's talking about the sides only. So this one's saying if AP, so the ones that touch the vertices, are now your perpendicular bisectors. Or in this case, they're your angle bisectors because they create 90-degree angles. So these are your angle bisectors. When they touch the vertices and they're given to you, these are your angle bisectors because they give you 90-degree angles. So that means the ones that touch the sides, like PD, PE, and PF, are all congruent to each other. Let's try out a couple of examples. Here's extra practice towards the bottom dealing with end-center. So it says N is the end-center of ABC. So use the information given to find the indicated measure. So it says here that ND is 2x minus 5. So let's go ahead and label it. ND is 2x minus 5. And NE is negative 2x plus 7. We need to find NF. Okay? So N is the end center. And so that means that when N is the end center, that means that the parts that touch the sides, they don't touch the vertices. The ones that touch the sides are all congruent to each other. So that means that ND is congruent to NE, which means it also has to be congruent to NF. So all three of these sides have to be congruent. So that means all we have to do is set these equal to each other. So we have 2x minus 5 equals negative 2x plus 7. And we know that anytime this happens, we also know that this will equal NF, whatever NF should be. So let's solve for this part. So we have plus 2x and we are left with 4x minus 5 equals 7. And so I'm going to add both sides. And so now I have 4x equals 12. And I divide by 4, x equals 3. I'll move this up so you guys can see. So all I did was solve for x. But I'm not done there. I have to plug x back in to find out what NF is. Because NF is the same as NE, which is the same as ND. So let's choose either one. Let's go ahead and just use 2x minus 5. So I have 2 times 3 minus 5, 6 minus 5, which equals 1. So NF equals 1. Okay, let's try another example. So NG is x minus 1. And NH is 2x minus 6. We need to find NJ. And our end center, because they are perpendicular bisectors, we note that the ones that are touching the sides of the triangle, not the vertex, the ones that are touching the sides of the triangle are going to always be congruent. So all I have to do is set these two equal to each other and solve for x, and then make sure I plug x back in order to find NJ. So I have x minus 1 equals 2x minus 6. So I'm going to add x to both sides, or subtract x from both sides. These cross out, so I have negative 1 equals x minus 6. Going to add 6 to both sides. So 5 equals x. But note I have to plug x back in. So let's do the easier one for NG, because NG I know equals NH, which equals NJ. NG is x minus 1, which equals 2x minus 6, which will equal NJ. X is 5. 5 minus 1. 2 times 5 minus 6. So 5 minus 1 is 4. This one I have 10 minus 6, which is 4. So NJ equals 4. Alrighty, now let's try the last one, number 3. So I have NK, NL, and NM. So NK is x plus 10. And NL is negative 2x plus 1. So note all these three have to be congruent to each other, so all I have to do is set these equal. So I have x plus 10 equals negative 2x plus 1. I'm going to add 2x to both sides, and I end up with 3x plus 10 equals 1. I'm going to subtract 10, so 3x equals a negative 9, and I divide by 3, x equals a negative 3. Now it's okay to have a negative x value, because all I have to do is plug it back in. And so I should have a positive value when I do plug it back in. So I have x plus 10, and I can plug in x, so let's do 3, negative 3 plus 10, which equals 7, and that equals NM. Alright, let's turn over to the next page. We have some more practices here. So this time it says 4 through 7 to find the indicated measure. So PA we need to find, but I'm already given that PB and PB is 13. And so note that P is like our incenter, and I have perpendicular bisectors here. But I actually know this from P is the circumcenter. And P is the circumcenter because of the distance from the vertice to the center of our triangle. And circumcenter says, if we go to that first page, that they're congruent to each other if these are perpendicular bisectors. Okay? So that means if PB is 13, then PC must also be 13. And that also means that PA is also 13. Alrighty, let's try PS. PS, I have congruent angles on all sides, and I'm given P is still my center, and I'm given that these are congruent to the side. So P in this case is the incenter. So if P is the incenter, that means that PU is 8. That means PT is also 8, and PS is also 8. Okay, let's try 6 and 7. So GE, so we're already given that GD is 10, okay? And we need to find GE, and you guessed it, GE is also 10. This one very well is like our angle bisectors, because these here in line with G is very similar to the one that we did in our last section. these two sides are congruent to each other. So it means our top angles must be congruent. So GE is 10. For NF, it's hitting to the sides. So when it hits our center to the side parts, and I'm given that value that hits to the side part, that means N is the end center. So that means that ND is 2 and NF is also 2. Okay, moving on to our next three examples, 8, 9, and 10. It says find the coordinates of the circumcenter of the triangle with the given vertices. So this one has a couple of steps to it, and this is where you're going to need to find the midpoint. You're going to need to find the midpoint of both of these triangles, or both of these coordinates, or in between all of these coordinates in order to find the circumcenter of the triangle. Okay? So, first thing you need to do is graph all of your points. So I have these drawn ahead of time because they might not be drawn to scale if you just drew them any kind of way. So A is negative 2, 2, or negative 2, negative 2. B is negative 2, 4. And C is 6, 4. So a little hint is to find the circumcenter of your triangle. It's normally going to lie on the longest side. So it's going to lie somewhere on AC. But in order to do that, you kind of need to find the perpendicular line that passes through both of them. So I got to find the midpoint of AB. So to find the midpoint of AB, you can use the midpoint formula, which I'll write here. Okay, you can always do that, or in this case, we can always count to the very middle. So in this case, we have 1, 2, 3, 4, 5, 6, 7. So in the middle of that would be 3. 1, 2, 3. Hit 1, 2, 3. Okay, so this is our middle. So in the middle of that, it would be negative 2, 1. Okay, and then we'll do the same thing for B. So the midpoint of BC. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. In the middle of that, you know, let's count towards center. And so that center is, count 1, 2. And you're going up 1, 2, 3, 4. Alrighty, so at this point, I have these dotted lines. If I were to create a line all the way downward that corresponds to this and all the way across, there is a point where they meet. And the point that they meet at is right here. So, in other words, you can always take AB went up and down, correct? So that's pretty much it went like the Y value. So you're going to actually choose the Y coordinate of your midpoint. BC went horizontally, so like through very similar to the x-axis. So I'm going to choose the x coordinate. So, and where they meet is actually at 2, 1. And so that is your circumcenter. So let's try it for number 9. So graph your points first. So while I'm graphing, I have D is 3, 5. E is 3, 1. And F is 9, 5. So again, we're going to find the midpoint of each of these. So the midpoint of DE what is the midpoint of DE? So we can always count 1, 2, 3, 4, 5. So it would be right here in this middle, which is at 3, 3. And then we'll do the same thing for DF. So midpoint of DF, 2, 3, 4, 5, 6, 7. So I would be there, and that point is at 6, 3. So here are my dotted lines that correspond to it. Perpendicular. We're talking about perpendicular bisectors, so they have to cross to make a 90-degree angle. And so they actually meet at this point. No, it's not drawn scale, but that is okay. And we can also note that on DE, it's going up and down, similar to the y-axis. So I'm going to choose the y-coordinate. And on DF, it's similar to the x-axis, so I'm going to choose the x-coordinate. So it is at 6, 3. Okay, so let's try number 10. So here's my line I'm choosing from. So graph your points. The J is 4, negative 7. And then K is 4, negative 3. And L is negative 6, negative 3. Alrighty, so now we got to find our midpoints of each one. So this one, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the midpoint of LK is here. So no, I didn't just count, but again, you can always use the midpoint formula. So, and that point is at negative 1, and I went down to negative 3. Okay, and then we'll do the same thing. Midpoint of KJ is there, and so that is at 4, negative 5. So note KJ went horizontally like our y-axis, so, or went vertically like our y-axis. We're going to choose the y-coordinate, negative 5. And LK went horizontally like our x-axis, so I'm going to choose the x-coordinate. And so I have negative 1, negative 5 as my circumcenter. No, but it's not drawn to scale, but the line probably went across there. Alrighty, and that concludes our 6 points we know. You do have a puzzle on this side that you'll have to go through, and it has a couple of examples here, and make sure you answer the puzzle riddle. And then there's also a worksheet that's very similar. There's also a worksheet that you'll work on, and it's 6.2 and 3, so you'll also get 6.3 notes to work on as well. Thank you so much.